Section 5.4, question P34. So we have a card drawn at random from a 52 card deck. And you don't need to know much about cards other than there's 13 denominations, ace, 2, 3, 4, all the way to 10, jack, queen, king. And there's 4 suits, hearts, spades, clubs, diamonds. So using the definition of independent events, let's determine which pairs of events are independent. Most importantly, make sure you do not confuse this with mutually exclusive. So mutually exclusive and independent are two separate things. Here we're looking at independence. So for example, getting a heart and getting a jack, you could potentially have a card that is both, the jack of hearts namely, but that doesn't affect the independence necessarily. So we need to take a look, and the formula that we're using here is the probability of A and B equal to the probability of A times the probability of B. Okay, if it is, then we have independent events. Okay, so the probability of A and B would be probability of heart and jack in our case. Well, if we need to have a heart and we need to have a jack, in other words, we need to have the jack of hearts, there's only one out of the 52 cards that's going to give us that. So that's what we're looking at as the intersection of those two events. Probability of heart times probability of getting a jack would give us, probability of giving us a heart would be 13 out of 52, because we have a heart in each of the denominations, ace of hearts, 2 of hearts, 3 of hearts, all the way up. We have 13 different hearts and 52 different possible cards. Now jacks, we would have 4 out of 52. Okay, because we would have jack of hearts, jack of spades, clubs, and diamonds. So 4 out of our 52 cards in the deck would be jacks. Now if we multiply these across, we're going to, let me put it down here, 13 times 4 will give us 52. And on the bottom, instead of actually multiplying those out, I'm just going to keep them as 52 times 52. The reason being because we can quickly see here that 52 will cancel, and so we'll end up with 1 over 52. So the probability of the hearts times the probability of getting a jack is 1/52, and the probability of getting both at the same time is a 1/52. Since those are equal, we do know that these are independent events. Getting a heart and getting a red card, so we're going to clear this, and let me just do kind of an abbreviated version. So probability of both would be a heart and a red card would have to be a heart, right? So to get a heart, we would have, maybe I should put it at least like this. So heart and red. Well, if we have a heart, we automatically have a red. If we have a red, we don't necessarily have a heart. So as long as we have a heart, we are satisfying both categories. So in order to get a heart, there would be 13 options out of 52 possibilities. Now if we look at the probability of heart times the probability of red, we've already calculated the probability of heart would be 13/52. And the probability of getting red is, we could write 26/52. 26 of the 56 cards are red, or we just know 1/2. 1/2 are red, 1/2 are black. So if these, when we multiply it out, equals this number right here, this fraction right here, then it is independent. But we can quickly see that it's not, because we see this same fraction appearing right here, and then we're multiplying by half. So we're only going to have half. We're going to end up with 13 over 104, which is much less than 13 over 52. It's half of it, to be exact. But it's certainly not equal here, so they are not independent. Getting a 7 and getting a heart, maybe I can just put it down here. So probability of 7 and heart. Again, to have both of them, there's only one card. I'm getting trigger happy with my pen here. Switch it around. Okay. And probability of 7 times probability of heart. By the way, I really do have good handwriting. It just doesn't show up on a tablet pen. Probability of 7 would be 4. There's 4 7s in the deck, 52 cards. Probability of heart is 13 out of 52. We add that this is going to be the exact same multiplication as problem number 1. We'd get 52 over 52 squared, which ends up being 1/52. So because they're equal, they are independent events.